Topic 1. The interface. The interface must never reach the disk stack or pass the outer edge of the top disk. Process variables affecting the position of the interface are density, viscosity, temperature, flow. Topic 2. Density. U-tube. Consider the U-tube containing oil and water. The oil density depends on the type of oil, fuel or lubricating, and its quality. Generally, the oil has a lower value for density than water, as shown. Examples of typical densities are shown below. At 15 degrees Celsius, water, 1,000 kilograms per cubic meter. Seawater, 1,024 kilograms per cubic meter. Oil, 980 kilograms per cubic meter. For an equal volume, the weight of oil is less than that of water, and it is described as being lighter. The oil and water in opposite sides of the U-tube attain a balance because of their respective weights, the level of the heavy water being lower than that of the lighter oil. Oil with lower density. If an equal volume of oil of a lower density were to be put into the U-tube, the level of the oil would be higher, as this oil is lighter. The level of the water would be lower to maintain the balance. Within the U-tube, the balance is always maintained by the adjustment of the levels of the oil and water and the movement of the point at which the oil and water meet. The point at which the oil and water meet is called the interface. Oil with higher density. If an equal volume of oil of a higher density were to be put into the U-tube, the upper level of the oil would be lower, as this different oil is heavier. As the upper level of the oil has moved down, so must the lower level of the oil move down, and consequently the upper level of the water would move up equal to maintain the balance. U-tube to separator. The separator bowl follows the principle of a U-tube. A continuous tank operation. The oil and water mixture is fed into the tank. The oil and water outlets from the tank have been arranged as overflows from the tank. The positions of the overflows have been arranged to correspond with the heights of the oil and water attained in the U-tube. There is still a kind of U-tube principle in this tank, with hydraulic balance being achieved due to the weight of the oil and water respectively. The point at which the oil and water meet is called the interface. Interface at different densities. We now consider an increase in the density of the oil. The position of the overflow outlet of the oil is fixed, so the oil level cannot move upwards. All the movement will be at the interface, which will move downwards, and some water is consequently displaced from the water outlet. If we now consider a decrease in the density of the oil is lighter, and the interface is displaced upwards by the heavier water. Centrifugal operation. This is the same as with the continuous tank operation, with gravity being replaced by centrifugal force. An increase in the density of the oil will move the interface outwards. A decrease in the density of the oil will move the interface inwards. Topic 3. Viscosity. Flow dependent on viscosity. Viscosity is a measure of how fluid a liquid is. Viscosity of a liquid can be determined by allowing a known volume of a liquid to pass through a small hole of known diameter and recording the time taken. There are different units of measurement. In this instance, we will talk about centistokes. It is quite easy to understand that a thicker liquid will take longer to pass than a liquid that is thinner. It is generally accepted that less viscous liquids flow better in pipes and are more pumpable than liquids with a high viscosity. Centrifugal operation. Let us consider the separator is running with the interface positioned just outside the edge of the disk stack. When the dirty oil is fed into the center of the bowl of the centrifugal separator, it moves outwards under the distributor. The water moves outwards from the interface. To get to the oil outlet, the oil must pass across the disk stack. Disk stack. The disks are designed to be close together to minimize the distance the small particles have to travel. However, the thicker or more viscous the oil is, the greater will be its resistance to travel in the direction required. The resistance of the oil to move inwards results in the interface moving outwards slightly. Increase and decrease of viscosity. Larger increases in viscosity can result in the interface being pushed outwards past the outer edge of the top disc. Oil then passes out of the water outlet. The separator bowl is then said to have lost its water seal. Conversely, a decrease in the viscosity results in the interface moving inwards. Water can then block the disc stack. Topic 4. Temperature. Temperature versus viscosity. When preparing oil to be separated in a centrifugal separator, we have to consider how viscous it is. Gas oil is not very viscous. In fact, its viscosity is very similar to water, and consequently it is not necessary to heat it to reduce its viscosity. On the other hand, heavy fuel oils and lubricating oil are much more viscous, and have to be heated to reduce their viscosity to enable them to pass more easily across the disc stack to the oil outlet. This reduction in the viscosity of the oil also makes it easier for the solid particles to come out. Remember Stokes' law. Temperature versus density. Temperature also has an effect on the density of both oil and water. This is shown in the density versus temperature graph. By heating the oil, we can reduce its density below that of the water. Topic 5. Flow. Flow dependent on viscosity. The separator has a limit to the flow rate it can handle, above which point it will be unable to swallow what is being fed. The amount of liquid it can swallow also depends on the viscosity of the liquid, since this determines how it passes across the disc stack. With no change in viscosity, an increase in flow will result in more oil passing across the disc stack. This will move the interface outwards. For a decrease in flow, the interface will move inwards. Summary. Effects of process variables. Click the buttons to increase and decrease the variables, moving the interface. Level ring. In the balanced U-tube and the continuous tank arrangement, the highest level is that of the oil. Click on the button to see the concept shown in centrifugal separation. In the centrifuge, to maintain the inner level, that of the oil, at a constant position, a weir is fitted in the neck of the top disc. This weir is called the level ring.